All right, guys, so a question was asked on the 4.2 worksheet on problem number 11, and I went over this in class, but I'm not sure that everybody saw it, so I thought I'd make a quick video explaining this. Okay, so we've got a quadratic function here in standard form, and I think the question was asked because people were doing the right work here so far and then just ran into a little snag. So let's see what we've got. In standard form, we're going to use this formula of the opposite of b over 2a to find the x-coordinate of our vertex, or the axis of symmetry. Now, b is negative 18, so the opposite of b is going to be positive 18. Down in the denominator, we've got 2 times a. Our a value right here is negative 2. 2 times negative 2 is going to get us negative 4. And no, your eyes do not deceive you, everybody. 18 does not divide by negative 4 evenly. So what I would expect you guys to do would be, to go to your calculator here, your TI-84, and type in 18 divided by negative, I gotta hit the shift button there, negative 4, and we end up with this decimal answer right here of negative 4.5. And I know you guys don't like that, but dang it, go away. All right, here we go. We should be able to work with that. So negative 4, that point will work just fine there, 0.5, that's our axis of symmetry. So I guess I could label that right here. Axis of symmetry is the vertical line x equals negative 4.5. And we're going to use that now to help us fill out our table. So x column and y column, or f of x. And just like always, we need 5 values here. And then this value that we just came up with, negative 4.5, we have to include that in the middle of the table. But the reason this one got brought up, I think, is because the way we've had our tables set up in class, a decimal value like negative 4.5 isn't going to show up. So let me show you guys how to get around that on the TI-84. Now on this keypad on the left, everybody, watch what lights up in red. That'll show you what buttons I just hit. But what we're going to do is, like always, we're going to hit the y equals button right here. And if you have any junk there, which I do, we're going to clear out everything there. So we're looking at a blank page. And just like always, we're going to type in this quadratic function, which was a negative 2 and then x squared, and that's as much as I can remember, minus 18x, and a minus 39. We will hit enter from there, and then when we go second and then F5 to get to a table, ooh, mine's in a weird spot, I'm going to scroll up a whole bunch, but obviously you can tell all the values we have in this X column are integers. Now we need to know what happens when X is equal to negative 4.5, and that doesn't show here somewhere. So there's a way around this, everybody. So here's what we're going to do. We're going to hit second, and then the F2 key that says window. If you look up above that in blue, table setup. So second F2 is going to get us here. And then I don't care too much about where table start is, but we're going to go down one level here to that little triangle means delta, or change in table. And instead of a 1, I'm going to type that in as a 0.5 and hit enter. Now take a look at what happens when we go back to our table. Second, and then F5 again. And now you will notice that the X values are going up by 0.5, not just by 1. And so sure enough, right there is the negative 4.5 value that I needed to see. And the Y value I need going along with that is apparently 1.5. So I now know the Y coordinate of my vertex is positive 1.5. So let me think about where I am right here now, guys. Oh, actually, I know a neat little trick right here. Let me do that line. My axis of symmetry is negative 4.5, which is, sure, we'll do that. A dotted vertical line right there, okay. And then our vertex is at negative 4.5 and 1.5, which is right about there. Okay, that's where we're starting. We still need to fill in 4 more values in this table right here, guys. Now to do that, nothing says we have to stick with these decimal numbers. So let's go back to the table here. I need 2 values, one here and one here, that are less than negative 4.5, and we would all prefer to graph points with integer coordinates. So I'm going to use this one right here, negative 5, 1. Looks like something I can use here, negative 5, 1. And then above that, no, I'd rather not use these. Those are decimals. No thanks. How about this one right here, negative 6, -3. So that is going to go right there. And now let's go below the -4.5. Okay, right there is a point with integer coordinates, -4 and 1. Gotcha. And then one more. There it is, -3, -3. Okay, so that's an ugly negative. All right, guys. So these 5 points should give us what we need here. Let's see if I can plot these. -6, -3 is right about there. -5, -1. I'm sorry, that should have been a +1. Let me slide that guy up. That looks a little better now. Okay. And then where are we here? We're at -4, +1, right about there. Sure, close enough. And then -3, -3, right about there. Now, before we fill everything in, make sure this does what you think it should do. We know it's a parabola because of the x squared. Our a value here is -2, which tells us two important things. Number one, this parabola opens down, and my 5 dots sure look like a parabola opening down. And with an a value of -2, ignore the negative here, 2 is greater than 1. That means your parabola is stretched vertically. It's taller than a normal parabola, which gives it the appearance of being skinnier. And so, yeah, I feel pretty good about this graph. So I'll go ahead and plot that there. Sure, and then that there, and luckily we're not being graded on our artistic ability. And that's what number 11 should look like. Now at this point, guys, as soon as you get done with this problem, I would go back to your calculator, and once more I would go to second, and then F2, the window key, and I'd go change that delta table back to +1. Otherwise, that'll probably just annoy you on the next problem. So here you go, back to the table, we're back to just integers there. And that's what that one should look like. So that's how you handle a quadratic equation whose vertex has non-integer coordinates. And just like always, guys, there's your vertex standing alone. A downward opening parabola doesn't have a minimum value. It goes down forever on both sides, but it does have a maximum value right there. And sure enough, that 1.5 is the highest y value you will find in your table. And it should have symmetry around the vertex, 1 and 1, -3 and -3. So even though we've got some ugliness right here because of the decimal, this still does what every quadratic function out there should do.